MS Ramaya University of Applied Sciences.
Hi students, let us discuss the use of Coordinate Measuring Machine (CMM). The two main applications of CMM is part inspection and reverse engineering. Reading a micrometer with standard scale, least count 0.01 mm. Reverse engineering. It is a process of generating engineering design data from existing components. CMM is used for inspection and part approval of complex parts that are difficult to inspect using conventional measuring equipment. A coordinate measuring machine is a device for measuring the physical, geometrical characteristics of an object. This machine may be manually controlled by an operator or it may be computer controlled. Measurements are defined by a probe attached to the third moving axis of this machine. Three important steps in CMM operation. 1. Inspection planning. 2. Basic measurements. 3. Measurement of geometric dimensions. 4. Inspection report generation and part approval process. Understand the geometry of part to be measured. Size of the part. Smallest dimension in the part and its tolerance. Fixture arrangements. Critical dimensions of the part. Defining planes for measurements. Selection of coordinate system. Type of output.
Hello students, the next experiment is demonstration of CMM operations. You are seeing a CMM or a coordinate measuring machine. The CMM is basically used for doing or getting the measurements and reverse engineering applications. Now let us understand the construction of the CMM. The CMM is standing on a four-legged metal stand. The stand is supported by vibration damping rubber pads. The stand supports a granite surface plate. This is the granite surface plate on which the component will be placed for measurement and or for reverse engineering. This is the bridge type configuration of the CMM machine. This is the x-axis. This is the y-axis. This is the z-axis. One can see the probe adapter and the probe fitted or mounted to the z-axis or the z-axis. The XY movements are controlled by the XYZ control knobs. So this is the on and off position. These are the knobs used for fine adjustment of the X and Y axis. For the Z axis, one can find the fine adjusting knob near to the Z axis. So this is the Z axis fine adjustment knob, and two more additional axes which is mounted to the probe. You can see A axis and B axis. Next important part of the CMM is the air regulator unit. The air regulator unit has a air filter, mist separator, silencer and a pressure regulator pressure gauge. In order to operate the CMM machine, one has to maintain a pressure of 0.35 to 0.4 megapascal of air pressure. Now let us prepare the CMM for measurements. We need to clean the X, Y and Z axes before starting the measurements. We are using isopropyl alcohol or IPS solution to clean the axis of the CMM machine. You can see the isopropyl alcohol in this plastic container and a soft tissue. So now I have the IPA solution on the soft tissue. I am using this for cleaning the X, Y and Z axes. Now one part of the x-axis is cleaned, the other side we will clean the x-axis. One cannot clean the y-axis since the y-axis is within the machine, so cleaning of y-axis is difficult and not usually practiced before measurements. Now I am cleaning the z-axis. Now let us see the x-axis movement. I am switching on the x-axis now. I am moving the x-axis left and right. As you can see, all the movements are happening due to the air bearings on the slide. You can see the y-axis movement. Now let us move the z-axis. This is the z-axis on and off knob. A very smooth flow or a very smooth transition of the z-axis. Now the next step in preparation of the CMM is to make the axis or to bring the axis to the home position. We have a mCosmos software which will help us in doing the measurements and home position. Now next thing, you open the mCosmos version 4 software. Now let us open the mCosmos software and complete the homing operation. You can see X, Y and Z axes, and you can also see the red pointers. Once the homing is completed, all these pointers will turn to green, indicating that the CMM has reached the home position. Now I am doing the homing for the y-axis. So y-axis home position has reached, and on the screen you can see the red pointer turning to the green pointer with respect to the y-axis. The next is the x-axis. I am bringing the x-axis to the home position, and similarly now you can see on the software the y-axis red pointer turning into the green. The last is the z-axis, which I am moving to the home position. Now one can see the homing position, and these are the positions of the x, y and z axes. Now let us open the mCosmos software.
Richard Toyo, Parts Manager.
So this is the part manager of the mCosmos. You can see the different parts which are measured here like this. So the first thing, we will create a new part. Part A, B, C. So this is the file part ABC, in which all the dimensions and measurements will be stored. Now the next step is to go to the CNC learn mode. So this is the learn mode. This is where we will be doing our measurements. The next step is defining the probe. So you can see the probe menu falling down. You can see the different options. Then I am going to the probe data management. You can see the initial probe, the diameter of the probe, the difference, the A axis, B axis, X, Y, Z axis. Now before starting the measurements, one has to calibrate the probe and see that he is having minimum error in the diameter of the probe. So let us start the calibration process. So I am pressing the calibrate. In the calibrate, you can see lot of options. As of now, we are having the master ball diameter, which is 19.9293, which will be used as a master to measure the probe, and we are going to use probe factors as 5, that means 5 contacts. So I am going to say OK. Now the CMM is asking for the first point out of the 5 contact points, and you can see all the probe details. Probe number 1, angle A0, angle B0, sleeve length 63.500. Now let us start measuring the probe. Now I am going to get the first point. This is the crystal ball. This is the master probe. I got the first point. Second point. Third point. Fourth point. Fifth. Now the calibration process is complete, and one can see a error of about 0.00329 microns. Now this is quite an acceptable error, since the probe diameter is exactly 3.000. and we have got almost about 3 microns error, and we can use this probe for the measurements. So I am just saying OK. Now the probe is ready for measurements. Now before getting into the measurements, let us understand the accuracy and precision of the instrument. The accuracy of the instrument is minimum 3 micrometers, and it depends upon the length of the measurement. The precision is about 0.0005 or say 0.5 micrometers. Now let us start measurements. This is a model component. It is an injection molded component. One can see different types of configurations or different types of geometries on the surface. You are having a cylinder, you have a sphere, you have a cutout section like this. So all these dimensions can be easily measured in this CMM. As a beginning, let us measure the diameter of this sphere. The sphere. So I am mounting the component on the surface plate. Now I am choosing the sphere option, and you can see the sphere. The name of the sphere, let us call it as sphere A, and we are using 5 points to measure the sphere, and these are the different options. Let us keep it to the default options and start measuring the sphere. So you can see here the CM is waiting for the first point. So I am going to measure or say do a first point contact. So first point contact is completed. Next, the second point contact is awaited. Second is completed. Third point is completed. Fourth point is pending. Fourth point is completed, and the fifth point is expected. Now you can see the sphere geometry is being generated on the graphics window here, and you can see also the diameter of the sphere. You can see diameter is 19.9292 and number of points are 5. So for this sphere, this is the command, and you can see 0.004 is the program code, and these are the XYZ coordinates. Similarly, one can measure other geometries like cylinder and circle using these commands. Now let us do one inspection demonstration. You can see the different configurations here, different cutouts here, and there is a hole, a through hole, which is measuring 20 mm, and the tolerance is plus or minus 0.1 mm. Now let us measure this circle and find out what is the true dimension of the circle. Now I am choosing the circle option, and circle name is circle number 5. We are choosing number of points are 4, and now once I give OK, you can see the circle symbol here, and the CMM is waiting for the first coordinate points. So let us get the first coordinate points. The first coordinate point is obtained, second coordinate point is obtained, and the third is obtained, the fourth coordinate point is obtained. Now the circle diameter you can see here as 20.0121 mm. So this completes the measurement of the circle diameter. Similarly, The geometrical tolerances can be measured by using the CMM. One can measure roundness, straightness, flatness, cylindricity, concentricity, coaxiality, parallelism, perpendicularity, roundness, and total runout for a given component. Hence, CMM can be used for measuring the dimensional and geometrical tolerances for the given component. This completes this demonstration of CMM operations used for inspections.
At MSR UAS, we spark your imagination unlike any other.